Hey guys, this is the homework for week number 5. So I'll go ahead and write that at the top so you can see it. So this is a video to help with those 3 topics. And so the first topic we're going to go over is this one about factoring by grouping. So it's topic, I'll write it a little bigger, but it says it here, HVT. So we have definitely gone through this before. I'll go through a couple examples just to show you again, but we were working on what we worked on last week had this as part of it. So if I'm trying to factor by grouping, this is where I have the 4 terms and I'm taking them in pairs. So I'm taking the first 2 and the second 2, and then just factoring out the greatest common factor for each group. So that's the step I do here is I take each group and do the greatest common factor. So for 4 and 2, I can take a 2 out with, it looks like, oh, sorry, I wrote that wrong. That's a 3. So I can take 2 out of each group, right? Which is going to leave behind 2s. And then if I take 2s squared out of 2s squared, it's just going to leave behind a 1. So I have that 1 there. I have to pay attention to this sign here. If it's a negative number here in the middle, if that's a minus sign, then this is going to be negative here. And so if I'm looking at 10 and 5, I can take out a 5, which is going to leave behind again 2s minus 1. And so this is where I get that matching piece. So that's one of my terms. And then my other term is the 2 pieces that are left over. So notice this is not a quadratic because it has a degree here of 3. So this is just a polynomial that we're factoring by grouping, but it works the same way. So it'll still be the same idea. So just a little bit of practice on that. Let's scoot it up to a higher level and see if we get a harder problem. So it looks like the numbers, get a little bit bigger, but overall it's going to be about the same amount of difficulty. So at this point, I'm all the way up here at 81. So I'll do this one, but nothing really changes in terms of difficulty other than they add more pieces. So this one definitely, it has like 2 variables as opposed to just 1, but it still works the same way. I'm still looking for the greatest common factor. So if I go through here then and group together these 2, and these 2. So 12 and 24 means I can take a 12 out, right? If I look at my t's, I have 3 in each group. So I can take t to the 3rd out of each. And then I have a u here, but there isn't a u here. So I can't, there's no u in the second term here. It's just 24t to the 3rd power. So that's all I can commonly take out, which is going to leave behind a u, right? Plus 2. So 24 divided by 12 leaves behind the 2. Then I take the t to the 3rd power out, so that's gone. So now for my second group, again, I look at that middle and I see it's a plus, so it's going to have a plus sign here. And then 3 and 6, I can take a 3 out, and then t squared, I can take that out, but I can't take a u out of both groups. So again, it's going to leave behind u plus 2. So even with more pieces, you're still going to end up with that idea of a matching factor, and then the 2 extra pieces will make up the other part. Something I want to point out at this point is that if you look at that second group there, do you notice how there are 3 t's in the first group and 2 t's in the second, which really means that you can still factor this. This can still be factored. So you can take a 3 out, right? And t squared. And so you end up here with 4t. And then the 3t squared came out to the front, so that's a plus 1. So I have these 2 pieces that make up this. And then I have this piece also. So really, if I was gonna type all that in, I'd probably put the 3t squared first. 3t squared, and then u plus 2, and then 4t plus 1. Let's type that in. I also wanted to just make sure that you understood that you could do that also at the beginning. So let me show you that too. U plus 2, and then 4t plus 1. Yeah. I just wanted to point out that here in this first step, so remember when we talk about factoring, the first step is to take out the greatest common factor. And that's just mostly so that you pay attention to it. It doesn't necessarily have to be here because here we did the greatest common factor at the end. We took out that last piece at the end. But at the beginning here, you could, if you look, I'm going to change colors real quick. If I come back up to the starting equation, I had a 12, a 24, a 3, and a 6. So that has a greatest common factor, right? Of 3. And then if I look at my t's, I have 3 here, I have 3 here, I have 2 here, and 2 here. So I can also take 2 of them out at the very beginning, which is, obviously the same thing I got here. So it doesn't have to be the first step. It's just a good way to remind yourself to check. If you get to the end and you realize that you have something like this, where there are pieces that are common, like you have common factors here, then in order for it to be factored all the way, you have to keep going. You have to keep factoring it. All right, good reminder. So I'm glad we did go forward and do that problem. All right, so in the next 2 topics are basically the exact same topic. So I'm going to scoot forward then here. So this next one that I have up on my screen is topic ENU. And then the other topic for the week is topic CJC, which, to be honest with you, both topics are the same. And the reason they're the same is because CJC is for Algebra 2, but ENU is for geometry, but it's the same topic. Like if you look at the title, it's the exact same. Solve a quadratic equation by factoring. So over here, then let's write a list of steps. So I would check for greatest common factor first, just as a reminder, which it's a good idea to get into that habit, which you'll notice I didn't check on the first one, but it is a good habit to, when you're practicing them, to always look at it just so you don't forget. And then the second thing you can check for is some of those special products that we talked about having to do with square roots. And then you would go through and do the X method or the X game, that product and some idea. All right, so if I'm looking at this, basically I have no greatest common factor. This is one of the special products, actually. If I'm thinking about it, I really could say that I can take the square root of 1v squared and the square root of 1, but I'm not going to do that for this one, just because I want to go through the process with you. So let's go through the X method with this. So I have a product of 1 and a sum of 2. So I'm looking for 2 numbers that multiply to be 1, but add to be 2, which that's pretty easy, right? 1 times 1 is 1, and then 1 plus 1 is 2. So 1 and 1, both positive. And then I can use the shortcut on this one because I have a 1 in the front. So I can just say that my answer here is V plus 1 and V plus 1. I wonder if, I'm curious to see if they'll make you, oh, they would want you to write it that way, I would say, because you don't have the option for a squared, because you could also write this as V plus 1 squared. But since they don't give you that option here in your answer, I think you have to list it out both ways. Just to point out, if you do view this as a special product, remember you don't have to use the special products, it just sometimes makes it easier. Basically, you fill in your parentheses with the square root of each piece. So if I'm looking at the square root of V squared, that's V and V, and then the square root of 1 is 1 and 1. And since this is positive here, this is the same. It's going to be the positive side to make that add up to 2. All right, let's clear all this and do another one. All right, so here's a good reminder here to go through, right, and do your greatest common factor. This one, oh, you know what? We're supposed to be solving this. Oh, Miss Gray, we just skipped a step last time. So I'll explain on this one what you're supposed to do since we didn't enter it. That's why it didn't mark us off. But instead of just factoring it, now we have to use the factoring part to solve. That's why here at the end it says F equals a number as opposed to like just typing in that factored form. So but it's still the same steps. We still have to factor first. So greatest common factor, and then I can check for the special products, which I don't know if I'll have on this one. I don't think so. And then I can do that X method if I need to. This is going to factor it. So this is how I get this whole situation factored. So first step is to get the equation factored. And then I'm gonna come down here, and the fourth step is gonna be set each factor, each piece that I'm multiplying, equal to 0. Here, we'll put equal 0 there. And then it's gonna give me a solution. So you may or may not remember this from third quarter, but we did do it. So I'm gonna come over here and say, well, 41f squared plus 34f equals 0. So I can't take a number out of the 41 and 34, but I can take an f out of both groups, right? So I end up with 41f plus 34 equals 0. And so these are my two factors now. I have factored this. And so now my factors are f and 41f plus 34. Remember when you were separating factors out? So I have 2 here. So I need to set each one equal to 0. So I'm basically literally just going to take it, f, and then put equal 0 at the end. For this one, 41f plus 34 equals 0. This is one solution. So when I'm writing my solutions in here, I'm going to put into my box 0. And then notice it says separate each solution with commas. So after the 0, I'm going to put a comma because I'm going to have another solution here. So now I'm going to come over here and say, okay, well, if the 41f plus 34 equals 0, then I need to solve for f by subtracting 34 from each side and then dividing by 41. So f equals this fraction, basically, which I can't reduce, right? So I'm going to put in negative 34 divided by 41. Oh, fingers crossed. Good work. So that's really what we're doing for each part. So let's erase all this and do another one. So I'm going to leave those steps over there so you can see that they're the same for each part. Okay, so I'm going to go through my list. Greatest common factor, not for 7, negative 12, or 5. Special products, 7 and 5 aren't perfect square roots. So no, I don't have anything like that. So I'm just going to go through the X method then. And I don't have a 1 in front. So this is not going to be one of those cases where I have the shortcut available to me, which is fine. So 7 times 5 means my product is 35. And then my sum here in the middle is negative 12. So if I think about the factors of 35, there's not very many, right? 3 doesn't work, 4 doesn't work, but 5 and 7 work, and that's about it. And then 5 and 7 are the ones that are going to give me the right combination, right? If I do a negative 5 times negative 7, I get positive 35. And if I do negative 5 plus negative 7, I get negative 12. So these are my two numbers that I'm going to rewrite. So I'm going to come down here and say 7y squared minus 5y minus 7y plus 5. So notice these two are the same that I used here to rewrite. Then I'm going to go through and factor by grouping. So let's change colors. Green seems good. So my first group, my second group, I have a y in common, which leaves behind 7y minus 5. Here I have a negative sign, so I'm going to take out a negative. But if I look, 7y and 5, there isn't a factor that's common to them except for 1. And that leaves behind 7y minus 5. So my two solutions are 7y minus 5 and y minus 1 are my two factors for this equation. And so now I have to do this last step. So now I'm going to come over here in blue and say, okay, set each factor equal to 0. 7y minus 5 equals 0, or y minus 1 equals 0. And so if I go and just solve these like linear equations, I have to add 5, right? So 7y equals 5 and then divide by 7. So this is one fraction. And then here I just need to add 1. So 5/7 and 1. Nice job. Okay, this one, if I go through, oh yeah, my steps, I don't want to get rid of them. Let's just erase all this. If I look for special products on this one, I do have special products for these. So what y squared is a perfect square and 144 is a perfect square. So I can double check to make sure it works, but it should. So if I look over here and say, okay, well, the square root of y squared is y. And then the square root of 144 is 12. And then I have a plus sign here in the middle, which means that these are both supposed to add up to 24, which they do, right? Because I'll have a positive 12 and a positive 12. So 12 plus 12 is going to make that 24. So really my solutions, if I do this step here where I'm setting each one equal to 0, they're the same. I have y plus 12 and y plus 12 equals 0. And since these are the same, I only have to do it once. I don't have to solve it twice. It's going to be the same solution either way. So I end up with y equals negative 12. So this time I'm only listing it once. Okay, I did want to point out to you why you have two solutions. And the reason that you have two solutions is because remember that the shape of a quadratic equation, when you graph it, is a parabola, that bowl shape, and it crosses the x-axis 2 times. So these two numbers are the solution wherever it crosses on the x. So in a problem where maybe you end up down here and you end up with x equals, 3 and x equals -5, let's say, this would be 3 and -5 here on the x axis. And that's where it crosses. In a situation like this, where you only have one solution, the situation is that hold on, I'll show you if I can ever get my pen to switch to eraser. Switch to eraser. Oh gosh, it's so difficult. Hold on, let me erase. Okay, so in a situation where you end up here with y equals -12, I just want to point out, first of all, that they decided to use the letter y, but typically you'd see x equals -12. But you'd have a parabola where -12 is down here on the x-axis, and you have a point, but it only crosses there because it doesn't go below the x-axis, or possibly it doesn't go above. You know what I mean? Like it's going to cross just at that one spot. Okay, let's see. I was going to jump into the other topic real quick and just double check that nothing seems any different. All right, so if you look at that first one for level 0, pretty similar to what we were doing. Yep, same thing. Some ways these are actually a little easier. Okay, so it looks like, this is at level 89 and it gets to be some pretty big numbers at that point, but I believe all that's factorable, right? 57, it's divisible by 3. So you could take a 3 out of that for sure, maybe a 6. No, not a 6, but a 3. Okay, I think that's probably enough. And I'm very happy to help you with any problems. You can always either ask me during class time, or you can send me an email with a screenshot of your problem and I can send you back some work on it. Okay, good luck. Let me know if you have questions.